Okay, so now how are we going to be able to calculate x and y intercepts algebraically, not with a graph? So we want to be able to do this algebraically. I need to review a concept with you. That concept is a very straightforward concept, actually two concepts. For an x-intercept, let's start off by saying for an x-intercept, that's where it crosses the x-axis, and you know and I know y must equal 0 for all of those. Otherwise, it wouldn't be on the x-axis. For a y-intercept, you know and I know x must equal 0. Otherwise, it can't be on the y-axis. We've got to know that. Here's the second concept I need you to really understand. If I have two things being multiplied together to give 0, then either the first one is 0 or the second one is 0, and on sometimes they're both 0. But the bottom line is if I want two numbers to multiply to give 0, if I want 8 times a number to give 0, that other number better be 0. And if I want 12 times a number to be 0, that other number better be 0. And if I want 0 times a number to be 0, it could be any number at all, including 0, which will give me 0. So when I have two things that multiply to give 0, either the first one equals 0 or the second one equals 0. And in mathematics, when we say or, we mean both could be 0 at the same time. Calculating the y-intercept. Sub x equals to 0. Let's remember why we're subbing x equals to 0. Because for a y-intercept, gosh darn it, kids, a y-intercept must have x equals to 0. Otherwise, it wouldn't be on the y-axis. So let's do a couple of these questions. Calculate the y-intercept of the following. We're going to set x equals to 0, which means it's y, 0 squared, plus 4 times 0, plus 7, which is 0 plus 0 plus 7, which last time I looked was 7. And that's all it takes. I do want you to tell me the set part. Tell me what you're setting equal to 0, and then off you go. The next one. So this is in standard form. This is going to be factored form. Set x equals to 0. Y equals 0 minus 4, 0 plus 9. 0 minus 4 is negative 4. 0 plus 9 is 9. 4 times 9 is 36. I don't know my times tables. 36. The answer is negative 36 because there's a negative, so negative times positive. Last one. This is vertex form. Nothing changes. You set x equal to 0. Y equals 2. 0 plus 3 squared minus 1. Order of operation kicks in. Y equals 2 times 3 squared minus 1. Y equals 2 times 9. You have to do the square first. 2 times 9 is 18. 18 minus 1 is 17. And I'm done. And just to make my point crystal clear, you have standard form. You have factored form. You have vertex form. Man, isn't math cool? We have all those different forms, and we can find the y-intercept simply by setting x equals to 0. Okie doke. That's the easy part. The question now is, how do we find x-intercepts algebraically without graphing? So, what we do is first we remember that an x-intercept means where it crosses the x-axis, which means you're going to set y equal to 0. So for each one of these, we're going to set y equal to 0. Let's do our work. So set, I want to use this pen. Set y equals to 0. 0 equals x plus 5 and x minus 3. Now this is where I need you to think. I have two things multiplying to give 0. They happen to be two brackets, two binomials, but it's the same idea as a and b. Either the first one is 0, or the second one equals 0. And now you've got a very simple equation to solve. X plus 5 equals 0. Take 5 away from both sides and you get x equals negative 5. Or x plus 3 equals 0. Take the 3 over to the other side and you get x equals 3. Those, ladies and gentlemen, are your x-intercepts, otherwise known as your zeros. Let's do the next one. You can't do this squared without factoring. And you have two choices for a question like this. There's an easy way to do this and a harder way to do this. Let's try the easy way to do this. That's what that means, doesn't it? It means to square it out. So if I'm going to set y equal to 0, that means 2x plus 7 equals 0. Now, do I have to do an either in this case? Because they're both the same, aren't they? So just one is fine, right? So instead of saying either, I can just say therefore. Now, if you want to write either and write it out twice and do it twice, be my guest, but I'm not going to. Now, we got to do some algebra here. The 7 goes over to the other side. It becomes negative 7. We divide both sides by 2, and we get x equals negative 7 divided by 2, or negative 3.5. We don't have to do it twice because it's the same factor. Looking at C, this is a trinomial. If I set y equal to 0, I can't solve that. I cannot solve this. Let me show you really closely what I mean. If I do this, I can't solve that. If I move the 24 over, I've still got x squareds, I've got x's, it's a mess. You can't solve that unless we factor. If we factor, we're looking for two numbers that multiply to give 24 and add to give 10. Ideas? Yeah? 6 and 4 work. So both positive gives me a positive 24. Both positive add to give me 10. So that is perfect. So this is going to become as an equal statement. So instead of having it in standard form, I have it in factored form. It's an equal statement. This I can solve because it's two things multiplying to give 0. One of them is x plus 6, one of them is x plus 4. Now, did you see all this work I went through to get the answers? I bet you can do it simpler. Can you tell me what x equals? Just by looking at it? X equals, yeah?
Negative 6 and negative 4.
You got it. And if you want to do that on the easy ones, full marks. And that'll give you the zeros or the x-intercepts or the places where the graph will cross the x-axis. Question? Yes?
So is the only way that we can find the x-intercepts when it's in the factored form? Like, is that the only form we can find it in?
That's right. That's right. Otherwise, it's really, really hard. Yeah. So factored form is needed to find the x-intercepts. You got it. Algebraically. Okay, so the last one, so we can finish this off. So this is in factored form. If I set y equal to 0, what I have is a mess. And up until today, you guys couldn't do anything with it. But because of today, you can factor, which means you're looking for two numbers that multiply to give negative 14 and add to give negative 5. I'm thinking, yeah? I'm thinking that's a good one. Are there any negatives that need to go in there? That's right. So I need, well, negative 5. So the 2 and the 7, if they're going to multiply to give a negative, one of them has to be positive, one of them has to be negative, right? For me to get a negative 5, I got to have a negative 7 there, because it'll be negative 7 plus 2. Check that it works. Negative 14, negative 5. So this is going to be, so if you just look at that, you can now say that the zeros or the x-intercepts are x equals negative 2 and 7. I'm going to stop the video there, and we'll be back later.